Welcome friends. In today's lecture we are going to start new chapter, that is shear and development length. Okay. Till now we have completed singly reinforced section, doubly reinforced section, L and TB. Okay. In today's lecture we will start the shear and development length chapter. Okay. So up till now we were discussing about the sizing of beam, how to fix the dimensions of beam, and amount of longitudinal reinforcement provided in the beam. Amount of reinforcement provided in the beam, but that reinforcement was the longitudinal reinforcement, means provided along the length of the member to resist the given bending moment. If you remember the structural analysis 1 or 2, you will come to know that in SA1 and SA2 we were finding two major quantities. One is shear force and second is bending moment. Okay? So the reinforcement to tackle with the bending moment, that is our longitudinal reinforcement, which we have calculated in our previous chapter. That is how to calculate longitudinal reinforcement for singly reinforced section, for doubly reinforced section, and for L or TB. Okay. But how to resist the shear force? How to resist the shear force induced in the beam, that we will see in today's lecture. Okay. Now let us see, when we are talking about the bending moment and the reinforcement required to resist the bending moment. See, when bending moment causes in the beam, it produces tension on the top of beam and compression on the top of beam and tension at the bottom of beam. Okay, if the beam is subjected to sagging bending moment. Now the compression part takes care by the concrete alone, that is our assumption, and whole tension will be taken by the steel reinforcement. Okay, so that's why the main reinforcement is provided at the bottom of beam. And two anchor bars are provided at the top. Now see, this is my beam and this is the reinforcement provided to take the tension, and this is just anchor bar. In double reinforced section, on the top of beam also there is a reinforcement provided. Okay. Now as I have told you in structural analysis 2, if the negative moment is caused, if the hogging moment is caused there, then definitely the reinforcement will be provided at the top. Okay, so we will not discuss in detail about that in today's lecture. So what is my point? See, in previous few lectures we were talking about this reinforcement. Means reinforcement provided along the length of the beam, means this reinforcement is provided. Suppose this is the beam and this is the direction of reinforcement. Okay, we were calculating 4 bars of 20 mm diameter, 4 bars of 6 mm diameter, means these bars are laid in the direction parallel to the length of beam. Okay, now see, if you have seen this reinforcement provided in the beam, all these bars are provided or mounted with the stirrups like that. If you have seen the reinforcement, and you might have come across this figure. Okay, such vertical stirrups are provided, such reinforcement is provided around the longitudinal bars in the beam. So what is the reason or what is the purpose of these vertical stirrups, or what is the purpose of this ring, you can say, rectangular ring? If the circular beam or circular column is there, then definitely the ring will be circular ring. Okay. So what is the purpose of this circular? See, the purpose of this circular ring is to resist the shear force. Okay. Now see, as we have seen in the singly reinforced section, when bending moment is there will be compression at the top and tension at the bottom for sagging movement. So the compression part will be taken care by the concrete and tension part will be taken care by the steel. Okay. Now similarly, when the shear force is there in the beam, every beam is subjected to shear force as well as bending moment. Okay. When the shear force is there, who will resist the shear force? Whether concrete or steel. Okay. So the answer for this question is some part of the shear force will be resisted by the concrete and some excessive shear force will be resisted by the steel. But which steel? This steel. This vertical steel. Now the shear reinforcement, that is called as shear reinforcement. Reinforcement or steel provided to resist the shear force. Reinforcement provided to resist the shear force. And this is called as longitudinal reinforcement. You can say tensile reinforcement. Reinforcement provided to resist tensile force. But this vertical stirrup is called as shear reinforcement. Now, whether the shear reinforcement is provided only in the vertical stirrup form? No. Shear reinforcement is provided in 3 different forms. These are vertical stirrups, second, inclined stirrups, and third, bent up bar. Okay. So this shear reinforcement is provided in 3 different ways: vertical stirrups, inclined stirrups, and bent up bar. Now see, this is the vertical stirrup. And in many cases, in general construction practices, if you see around your locality, you will come across this vertical stirrups only. Inclined stirrups is provided in some rare cases, as well as bent up bars is also an old practice. Now the shear is resisted by the shear reinforcement. Okay. Now before we start with the actual design procedure for the shear reinforcement, we should know some important terms related to this shear design or design of beam for the shear force. Okay, so we'll see that term one by one. So first is nominal shear stress. Tau V. It is denoted by tau V. It is called as nominal shear stress. So it is nothing but the actual shear stress in the beam. So again, stress means what? Force divided by area. As we are talking about the shear stress, it will be shear force divided by area. It's shear force divided by area. So it is equal to VU divided by, now area will be cross sectional area of beam. Area is the cross sectional area of beam. VU divided by BD. Okay. Now this VU is the factored shear force. VU is the factored shear force. B width of beam and D is the depth of beam. Okay. So this is nominal shear stress, tau V. You can also call it as actual shear stress in beam. VU divided by BD, or given shear stress in the beam. Okay, it depends upon your loading condition. What is your load? According to that, your VU will be calculated, and from that VU, your tau will be calculated. So it depends upon the given loading condition. So this is about the tau. Now, as I have told you that who will take care of this shear force, this or shear stress? It it will be sheared by the concrete as well as steel. So some part of the shear force will be carried by the concrete itself, and remaining excessive part will be carried by the shear reinforcement or steel. Steel means this vertical steel, shear reinforcement steel, not non-stable steel. Okay. Now the shear taken by the concrete is represented as shear taken by concrete is given as tau c. It is given as tau c. It is denoted as tau c. Now, how will you calculate this tau c, or on which factor this tau c depends? Okay, it's a shear taken by the concrete, so definitely it is not depend on the loading condition, but it depends on the grade of concrete. It depends on the grade of concrete, which grade you are using, on which it depends. Okay. Now see, in IS 456, this tau c values are given, or different grades of concrete. You can see such table in IS 456, which gives the design shear strength of concrete, means the shear taken by the concrete tau c. Now see the columns which gives M15 grade concrete, M20, M25 and M30. Okay, so for these 4 grades the tau c value will be given in IS 456. Now again, it not only depends upon the grade of concrete, it also depends upon the percentage reinforcement of tensile steel provided in the beam. So PT limit, it also depends upon the PT limit. So 100 multiplied by AS divided by BD. Suppose your percentage reinforcement of beam is 0.25 and grade of concrete is 15, so your tau c value will be 0.35 Newton per mm square. This chart is given in Newton per mm square. For the example purpose, I have given only 2%, 2 rows. I have mentioned here only 2 rows. So other percentage of reinforcement or other percentage of reinforcement, also the grade of tau c values are given in IS 456. After this lecture, you can refer the IS 456 and you can see this chart. Okay. So this value is very essential. This value is very important. Okay. So this is tau c. Then maximum shear stress in concrete, or maximum, another way you can say maximum shear stress in concrete. So it is tau c max. Now what is this tau c max? See, so this tau c max means what? Under no circumstances, your tau c value or nominal shear stress should exceed this tau c max. कोणत्याही केस मध्ये tau v ची व्हॅल्यू tau c max पेक्षा जास्त होता कामा नये. If your tau v is greater than tau c max, then you have to redesign the section. Okay. If your tau v is greater than tau c, okay, the excessive shear will be resisted by the shear reinforcement. But if your tau v exceeds tau c max, then you have to redesign the section. You have to change the sizes of beam. You have to straight away change the sizes of beam, or you have to change the grade of concrete. Okay? No other option. Your tau v value should be less than tau c max. Okay? And these tau c max values are also given in IS 456 for different grades of concrete. Okay? And it depends only upon the grade of concrete, not reinforcement percentage. See, these are the values. For M15 grade, tau v value should not exceed 2.5 Newton per mm square. For M20, tau v value should not exceed this tau c max 2.8. For For M25 tau c max is 3.1 and for M30 tau c max is 3.5. Okay, so for all these four grades M15, M20, M25 and 30 tau c max values are given. Okay, now these are the terms that tau b, tau c and tau c max. You should know by designing the beam. Okay, and these values are given in the IS 456. Okay. Now, what is the minimum shear reinforcement which is needed, which have to be provided in the beam? Okay, what is the minimum shear reinforcement as per IS 456? So, minimum shear reinforcement required as per IS 456 in beam is the value which satisfy this equation, that is ASV divided by V into SV should be greater than or equal to 0.4 divided by F1. I will elaborate the terms. What is ASV? ASV is the cross sectional area of stirrups. Then SV, center to center distance between two stirrups. Between two stirrups. Okay. Then B, width of beam. Okay. Now see this reinforcement of this vertical stirrup. If you see the beam, these vertical stirrups are provided like this. Okay. Now this SV means center to center distance between two consecutive stirrups. Center to center distance between two consecutive stirrups is your SV. Now how to calculate the ASV? ASV is the cross sectional area of this vertical stirrup. Now this stirrup is called as two leg stirrups. Means when I cut this section, I will cut these two legs of the stirrups. So it is called as two leg stirrups. Okay. So when I will calculate ASV, cross sectional area of ASV, so it will be pi by 4 into d square plus pi by 4 into d square. So it's a 2 multiplied by pi by 4 into d square. 2 multiplied by pi by 4 into d square. Okay. Then B is the width, Fy is the grade of steel, and the other values are, this is 0.4. Okay. So your minimum reinforcement in beam should satisfy this equation. It should satisfy this criteria which is given in IS 456. Okay. So this guideline is as per IS 456. So one more guideline is there, that this SV max provided in the beam means spacing between two stirrups, or center to center distance between two stirrups should not exceed 0.75 d or 450 mm, whichever is best. This SV max should be less than this. म्हणजे कॅल्क्युलेशन्स करून आल्यानंतर तुमची जी स्पेसिंगची व्हॅल्यू असेल, सी आता तुम्हाला हे शेअर एन्फोर्समेंट डिझाइन करायचे म्हणजे काय करायचं, किंवा हे शेअर एन्फोर्समेंट ची कॅल्क्युलेशन्स करायचे म्हणजे काय करायचे, तुम्हाला ज्यावेळी साइट इंजिनियरला हँडओव्हर करायचे. सो व्हॉट इज शेअर एन्फोर्समेंट? सो शेअर एन्फोर्समेंट म्हणजे तुम्हाला काय सांगायचं आहे की तुमच्या स्टिरअपच्या ती 2 लेग्ड आहे की 4 लेग्ड आहे. जनरली आपण 2 लेग प्रोव्हाइड करतो बीम मध्ये. सो त्या स्टिरअप्सचे डायमेन्शन्स मीन्स व्हॉट इट्स डायमीटर इज वन क्रायटेरिया अँड सेकंड इज द स्पेसिंग. व्हॉट शुड बी द स्पेसिंग बिटवीन टू वर्टिकल स्टिरअप्स. Okay, that you have to provide it to your site engineer. Okay, so that spacing should not exceed this 0.75 D or 450 mm at any case. तुमच्या कॅल्क्युलेशन समजा शेअर फोर्स कमी असेल तर कधी कधी स्पेसिंगची व्हॅल्यू 500 mm येते. सो 500 mm एवढं स्पेसिंग आपण बीम मध्ये प्रोव्हाइड करू शकत नाही. ऍक्च्युअल कॅल्क्युलेशन्स फ्रॉम द शेअर फोर्स and the procedure of the IS 4/6, if the value is 500 mm or 600 mm is the SV value, but you can't provide SV as a 500 or 600 mm. You have this limit 0.75 D. What is D? D is the effective depth of that particular beam and 450 mm. Now suppose this 0.75 D is 300 mm and this is 450 mm. So your SV value should not exceed 300 mm because whichever is less is mentioned here. Okay, so please note this also. These are the two guidelines regarding the minimum reinforcement. So this is one and this is regarding the spacing. Okay, when you design your beam shear reinforcement, you have to be very careful about these two guidelines. Okay. Now, how to design a shear reinforcement? What will be given and what you have to provide? As I have told you, what you have to provide? You have to provide just a spacing between two stirrups and diameter of stirrups. That is enough. That is the only shear design. Okay. Now, how to arrive at the spacing? How to calculate the spacing required for that particular beam? Okay. So for that, see, as I have told you, a different terms related to the shear reinforcement, that is tau v, tau c max, and tau c. Tau v, tau c max, and tau c. Okay. So what will be given to you? They will give you the shear force in the beam. They will give you the shear force in the beam is 40 kilonewton. The reinforcement provided is 4 bars of 20 mm diameter, M20 grade concrete, Fe415 grade steel. The depth of beam is 600 mm and width of beam is 230 mm. Design the shear reinforcement. So what is the given values? B is given, D is given, AST is given, VU is given. Shear force means VU is given. Factored shear force is given, VU. So B, VU, then AST, FCK, F1. All these values are known to you. Okay. So how will you proceed? See, first of all, you have to calculate tau v, nominal shear stress. So it is VU divided by B. It is VU divided by PD. VU is given, so you can calculate tau v, VU divided by PD. Then what is next? How will you calculate tau c? Next you have to calculate the tau c. How will you calculate tau c? It is given in IS 4/6. On which factor it depends? Grade of concrete and percentage reinforcement. So grade of concrete, again it is given. But how will you calculate percentage reinforcement? It's a simple formula. AST divided by PD into 100. You will get percentage reinforcement. You have to check the percentage reinforcement and your corresponding gate, you will get tau c. See, sometimes you have to do the interpolation and maximum times you have to do the interpolation. Okay, see, this is 0.25, this is 0.5, next value will be 0.75, but your value is in between 0.5 and 0.75 or 0.25 or 0.5, then you have to do the interpolation. Okay, so this is how you can calculate tau c. Then what is next? You have to compare tau v and tau c. You have to compare tau v and tau c. Once you calculated this tau v, first of all you have to check this tau v with the tau c max, as I have told you. Once you calculate this tau v, you have to compare this with tau c max. If this tau value is tau c greater than tau c max, you have to redesign this section. Okay? If this is okay, this value should be, or this value should not be greater than. If it is less than tau c max, okay. If it is greater, you have to change the dimensions b and d. Okay. Then you calculate tau c. Then you have to compare tau v and tau c. If tau v is less than tau c, if tau v is less than tau c, means nominal shear stress occurring in beam is less than shear taken by the concrete. इसका मतलब क्या है? Tau v is less than tau c means nominal shear force occurred in the beam, or nominal shear stress existing in the beam is less than shear or shear stress taken by the concrete. Tau c means shear taken by the concrete. Means there is no need to provide a design shear reinforcement. Concrete itself is capable to carry shear force or shear stress in the beam. Okay? मग आता गरज नाही म्हटलं तर प्रोव्हाइडच करायचं नाही का? असं नाही. You have to provide minimum reinforcement as provided in the IS 456. IS 456 ने सांगितल्याप्रमाणे मिनिमम शेअर रेन्फोर्समेंट जे ती प्रोव्हाइड करायचीच आहे. झिरो शेअर रेन्फोर्समेंट असा काही ऑप्शन आपल्याकडे नाही. ओके? सो व्हॉट इज दॅट मिनिमम शेअर रेन्फोर्समेंट? You have to go for this. Okay, if you rearrange this term, you will derive one equation that is SV is equal to 0.4. Sorry, SV is equal to ASB into Fy divided by 0.4b. Okay, you have to take the diameter of bar, which is going to be used as a stirrup, and you have to calculate the spacing. You have to check that spacing with these two criteria, 0.75d or 450 mm. If it is okay, or you have to select minimum of these three, this value, or this value. Means suppose from this equation you receive value 230 mm. From this 0.75d, let us say it is 250 mm, or you can say 350 mm, and 450 mm is given. Okay, so 230, 350 and 450 यातली जी मिनिमम व्हॅल्यू आहे ती तुम्हाला ॲज अ शेअर एन्फोर्समेंट स्पेसिंग म्हणून प्रोव्हाइड करायची फॉर दॅट पर्टिक्युलर डायमीटर. ओके, इज इट क्लियर? इफ दिस tau v value is less than tau c, there is no need to provide a design shear reinforcement. Only minimum shear reinforcement is sufficient. Okay, so the critical or the existing shear force, existing shear stress will be carried by the concrete itself only. You just have to provide the minimum shear reinforcement as per guidelines of IS 456. Okay, so you have to use this equation. You will calculate the spacing. Your design is finished here. Very simple design. Okay, but suppose, what is next possibility? Next possibility is that your tau v value is greater than tau c. Your tau v value is greater than tau c. Your tau v value is greater than tau c. In that case, what? Existing shear stress in beam is more than shear taken by the concrete. So there is an extra shear stress for which we need shear reinforcement, a design shear reinforcement. There is a special requirement for the shear reinforcement. So now for that case, how will you design? For that case, first of all you have to calculate what is the extra shear force available in the beam. So for it is denoted as VUS. It is denoted as VUS, extra shear force, for which we have to provide the stirrups. So it is directly calculated as tau V minus tau C into VD, or simply you can say it's VU minus tau C into VD. Okay, tau V multiplied by VD means VU. See here. Okay, you can use any equation out of these two. So this VUS is the force for which we need reinforcement, shear reinforcement. Then you have to provide the shear reinforcement. Now, as I have told you, you can provide shear reinforcement in three different forms. One, vertical stirrups. Second, inclined stirrup, and third is the bent up bar. Okay. So for all these three forms, there is a different formulas to calculate the spacing. Okay. So for vertical stirrups, SV can be calculated at 0.87 F1 ASV into D divided by VUS. Inclined stirrups same formula, only one term we will add here. Then bend up bar, bend up bar, the formula is okay. So in bent up bar there is no spacing. So bent up bars is provided along the length of beam. So there is no spacing criteria. You have to mention the number of bent up bars. 2 bent up bars of 20 mm, 3 bent up bars of 40 mm, like that. Okay. So that's why there is no spacing. Now see the terms. FY grade of concrete, ASV, the cross section area of vertical stirrups, the depth of beam, VUS is this. Okay. Then SV again similar, all the formulas. The only angle is alpha. Alpha is the inclination of that vertical stirrups with respect to horizontal. Okay. And this bent up bar again 0.87 Fy into ASB you can write here, because area of bent up bar into sin alpha. Again sin alpha is the angle of bent up bar at which it is bent. So generally it is 45. Okay. Now see, if you calculate VUS and if you are going to provide the vertical stirrup, then if you substitute all the values in this equation, you will get spacing. But again you have to check this spacing with the minimum reinforcement criteria. Okay, this spacing should not exceed the minimum reinforcement criteria, as well as 0.75 D and 300 mm. हे जे तीन criteria है, you have to calculate this SV. Then you have to check this SV to your minimum reinforcement criteria, means SV which is equal to ASV into Fy divided by 0.4, then 0.75 D or 400. Okay. Now once you calculate this SV, you have to compare it with this and this. And out of these 4 values you have to select minimum. या 4 व्हॅल्यू मध्ये जी मिनिमम व्हॅल्यू आहे ती तुम्हाला ऍक्च्युअल डिझाइन मध्ये घ्यायची. आलं की मीन्स your spacing should not exceed this value, should not exceed 0.75 D, should not exceed 400 mm. समजा एक्सीड होत असेल तर ह्या 4 पैकी जी व्हॅल्यू मिनिमम असेल ती तुम्हाला घ्यायची. Okay, similarly for this one also. Now what about the bent up bar? See, bent up bar cannot take 100% shear force for which the reinforcement is required. Means this VUS is, let us say, 100 kilonewton. VUS is, let us say, 100 kilonewton. So in that case, bent up bar will not take all 100 kilonewton. Bent up bar will contribute only up to 50% of total shear to be resisted. Means bent up bar will take only 50 kilonewton. For remaining 50 kilonewton, you have to design vertical stirrups again. For remaining 50%, you have to design vertical stirrups. So in that case, first of all, you have to select the diameter of bent up bar and you have to calculate VUB. You have to calculate. Means once you calculate this VUS, then straight away directly you have to go for the bent up bar calculation. Don't do that first. Okay? Then you have to, suppose you have selected 20 mm diameter bent up bar and 45 is the angle of bent up. You have to calculate this VUB by substituting all the relevant information. Okay? Once you calculate this VUB, you have to check that VUB whether it is more than 50% or less than 50%. If it is less than 50%, it is okay. If it is more than 50%, then you have to take it is maximum up to 50%. Maximum up to 50%. Means if it is, let us say, 55, you will take it as a 50 kilonewton. Now what is remaining shear stress? What is remaining shear force to be resisted? Again 50 kilonewton is remaining. So for that 50 kilonewton, you have to calculate the spacing of vertical stirrups. Means when you are going to provide bent up bar, you have to provide bent up bar along with the vertical stirrups. Okay? So bent up bar alone cannot resist all shear force which is need to be resisted. Okay? But vertical stirrups can do that. You can provide vertical stirrup without providing bent up bar. That is okay. Okay? So this is how the procedure of design. This is how is the procedure of design of shear reinforcement. In next lecture, we will solve a numerical based on the design of shear reinforcement. Okay? If you are having any queries regarding this, you can call me, you can WhatsApp me, you can ask your doubts by any means. Thank you.